Hi students, welcome to Max Point of View. Today we are going to solve each and every theory question from the chapter Electricity Part B, that is nothing but EMF, terminal voltage and internal resistance. So here we are going to solve each and every theory questions. Before this, you need to understand the concept. So if you haven't seen the concept video, then this session will be little difficult for you. So my suggestion is watch the concept video, then you come back to the solutions, then you will understand many things. So after solving this, we are going to solve each and every numerical. That video will also be available in the description box, and the concept video that is also available in the description box. Now without wasting any time, we'll start with the first question. Our next question, write an expression for the equivalent resistance of three resistors R1, R2 and R3 are joined in parallel and series. Just we have to write the expression. See what are the resistors R1, R2 and R3. So in parallel, we know 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. See, when it comes to resistance, okay, whether it is series or parallel connection, one definite question will be there in board exam. So this concept is very important. See, I have done the separate video for resistor, how to identify whether resistance are in series or parallel. After that, we have solved all the numericals from the textbook, okay, in this electricity part B numericals. That video is also available in the description box. Okay, now second one, when it is in series, Rs is equal to R1 plus R2 plus R3. So these are the formulas to find. If the resistance are in series, we are going to use this formula to find the answer. If the resistance are in parallel, this formula we are going to use. How to use it, how to get the answer, all those things explained in the numericals video. If you look into it and learn it, then definitely you will understand. Our next question, state how the two resistors joined with a battery in each of the following cases. So we have four different sub questions. We'll go one by one. Answer for the first sub question, same current flows in each resistors. When the current will be same, when the circuit is in series connection. We are talking about two resistors, right? When the two resistors are in series, current will be same. Keep this in mind. Current will be same in series connection. Okay, and voltage will divide in series connection. So in series connection, so when the two resistors are TWO, two resistors are connected in series. Okay, second sub question, potential difference is same across each resistor. See, I told you in series connection current will be same, but potential difference will divide. So but they are asking potential difference is same across each resistor. How can we make potential difference same in each resistors? When we connect two resistors in parallel, everything as it is. When the two resistors are connected in parallel, okay, then the potential difference across each resistors will be same. Potential difference is nothing but voltage. Okay, next, equivalent resistance is less than either one of the two resistors. Listen, when the equivalent resistance, that means total resistance will be less than the one of the equivalent resistance. Assume the given two resistors are 2 ohm and 3 ohm. How can we make the final complete resistance, total resistance is less than 2 ohm? So either one of the resistance, so less than 2 ohm. When this when the two resistors are connected in parallel, the total resistance will be less compared to the either one of the resistors. Assume the two resistors, okay, the answer is same. When the two resistors are connected in parallel is the answer for this one. How? Assume R1 is equal to 2 ohm and R2 is equal to 3 ohm. Okay, when you calculate the answer for Rp, 1 by Rp is equal to 1 by R1 plus 1 by R2. See, this explanation is not required in the exam, only this answer is enough. This is for your reference. So, substitute the answer 1 by 2 plus 1 by 3, answer will be 6. This will be 3 plus 2, it is 5 by 6. Okay, 5 by 6. Now, see, we are not finding Rp, we are finding 1 by Rp, right? So, final answer we have to take the reciprocal because it is 1 by Rp. If it is Rp, no need to take the reciprocal. It is 1 by Rp, take the reciprocal. So, it will be 5 by 6, it will be around 1.2 ohm. So, this is the final answer. So, they are telling, see, now you can understand equivalent resistance is less than the either of the two resistance. See, it is less than the either of the two resistance. When this is possible? When the two resistors are connected in parallel. Okay. Equivalent resistance is more than the either of the two resistors. So, when that is possible? When the two resistors are connected in series. This is the answer for the final one. Proof is not required in the exam. You take the same example R1, R2. R1 value is 2 ohm and R2 value is 3. So, when they are connected in series, we need to add them. So, that will be 5 ohm. So, this is nothing but equivalent resistance is more than the either of, see, equivalent resistance is more than the either of any one of the resistance. That's it. Our next question, state the differences between EMF and terminal voltage of the cell. See, EMF and terminal voltage. Okay, terminal voltage symbol will be capital V. Okay. See, first point, always go for definition. Just now we have learned the definition, right? So, first point, write the definition. Second one, okay, when the circuit is open, okay, EMF will be equal to capital V. See, capital V is nothing but terminal voltage. Keep that in mind. Okay, it is not television, it is terminal voltage. So, when the circuit is open, EMF will be equal to terminal voltage. The same thing you are going to write it here. Definition of EMF you are going to write here. Definition of terminal voltage. The next point will be when the circuit is open, when the circuit is closed, sorry, when the circuit is closed, EMF will be always greater than terminal voltage. Keep this in mind. So, here when the circuit is closed, terminal voltage will be less than the EMF. The same thing you are going to write. So, these are the differences between EMF and the terminal voltage. Our next question, name two factors on which the internal resistance of a cell depends and state how does it depends on the factors stated by you. So, we have to state the factors and how it is affecting the internal resistance. Okay, see the factors affecting, okay, internal resistance, that is nothing but small r. Okay, so we are going to use all these things in numericals also. That's why you have to be very careful. Capital V, okay, it is terminal voltage. EMF we know, we are going to write EMF. Small r, internal resistance. Capital R, the external resistance which we are going to add in the circuit. Okay, so internal resistance symbol is small r, but in the exam we are going to use the full form. The factors are surface area of electrodes, okay, and the second factor will be distance between the electrodes. Okay, see, between, you should write it in the expanded form. The surface area of the electrode, how that is affecting, see, these are the two factors. Now we are going to state how these two are affecting internal resistance. Surface area, the complete surface area of the electrode is inversely proportional to internal resistance. Inversely proportional, that means if the surface area is more, internal resistance will be less. So this is how surface area is affecting internal resistance. See, internal resistance will not affect the surface area, keep that in mind. Surface area will affect internal resistance. If the internal resistance is more, surface area of the electrode will not become less. Okay, surface area of the electrode will be always same, correct? We cannot decrease the size of the electrode. So if the surface area is more, internal resistance will be less. These two are inversely proportional. You can write any one. Surface area is inversely proportional to internal resistance, or if the surface area is more, internal resistance will be less. You can write any one of those things. Next, distance between the electrodes. If the distance between the electrodes are more, okay, more the distance between the electrodes, then more will be the internal resistance. These two are directly proportional. Distance between the electrodes, more the distance, more will be the internal resistance. So these are the two factors. This is how it is affecting it. Our next question, a cell of EMF E and internal resistance small r is used to send current to an external resistance R. Write an expression for the total resistance, the current drawn from the cell, the potential difference across the cell, voltage drop inside the cell. So all these things, for all these things we are going to write the expression. We'll go one by one. For the first sub question, okay, for the first sub question, the total resistance of the circuit, that is nothing but R plus R. Okay, the total resistance, this is the external resistance in the circuit, this is the internal resistance of the battery, this is nothing but the total resistance. Then we'll go for the second one, that is nothing but the current drawn from the cell. Current drawn, see, I is the symbol for current. So for this one, E by R plus R. E by R plus R. E is nothing but EMF. The complete resistance will give us the current drawn from the cell. Third one, the potential difference across the cell. Potential difference across the cell is nothing but the terminal voltage. Potential difference across the cell is nothing but the terminal voltage. Terminal voltage symbol is capital V. So to find this one, we have two formulas. One is I into R, okay, or V is equal to E minus IR. We can use any one of the things to find the terminal voltage. Next one, the last one is nothing but the voltage drop inside the cell. Voltage drop is represented as small v. Capital V terminal voltage, voltage drop small v. So capital I internal resistance. That's it. See, these are the expression they are looking for. Our next question, a cell is used to send current to an external circuit. Okay, in that first question, how does the voltage across the terminal compare with its EMF? We have one more sub question. First we'll solve the first sub question. See, how does the voltage across the terminal, what do you mean by voltage across the cell or voltage across the terminal? That is nothing but terminal voltage. The capital C, capital V is compared with EMF. When the current, see, they are specifically telling the current is sent. When the current will be sent, when the circuit is closed. When the circuit is closed, we know EMF is always greater than terminal voltage. Okay, terminal voltage. This is what they are looking for. Next sub question, under what condition is the EMF of the cell is equal to the terminal voltage? When, okay, EMF is equal to terminal voltage when the circuit is open. If the circuit is closed, EMF is always greater than the terminal voltage. If the circuit is open, EMF will be equal to the terminal voltage. This is only when circuit is open. That's it. This is when circuit is closed. That's it. This we have learnt in differences also. Our next question, the VI graph for a series combination and for a parallel combination of two resistors are shown in the figure. Which of the two, A or B, represents parallel combination? Give the reason for your answer. See, they have given voltage and I graph, current graph. In that there are two resistors, A and B. So out of these A and B, we need to identify which is parallel combination, whether this one or this one. If this is parallel combination, this will be series. If this is parallel combination, this will be in series. So we need to identify which is in parallel. See, in parallel combination, we know the complete resistance of the circuit will be very less. If the resistance is less, what about current? Current will be more. See, which line is towards the current? This line. That means this line has more current. So this slope A, the slope A has more current. You should not use the symbol since it is near to I axis. Okay, that means it has less resistance and we know in parallel combination resistance will be less. That's it. See, if the slope is near to I means it has more current. Where if it has more current, the resistance will be less. We know in parallel combination resistance will always be less. So this is the answer we are looking for. If the slope is near to voltage means it has less current. If it has less current, resistance will be more. If the resistance is more, B is in series. Resistance is less, so it is in parallel combination. That's it. Our next question, explain the meaning of the terms EMF, terminal voltage and internal resistance of the cell. See, what do you mean by EMF? First we'll talk about this one, EMF. See, whenever I write the answer, that will be in short form. So you have to form a proper sentence, proper English sentence using all the keywords which I am going to write here. Okay, listen. What do you mean by EMF? When the circuit is open, is open, potential difference produced by the chemical reaction between the terminals is called EMF, electromotive force. See, when the circuit is open, the potential difference produced by the chemical reaction between the terminals, okay, of the cell or the battery is called EMF. Now we'll talk about the terminal voltage. Okay, when the circuit is closed, the potential difference, okay, PD, the potential difference between the electrodes is called terminal voltage. What do you mean by terminal voltage? When the circuit is closed, the potential difference between the electrodes is called terminal voltage. Then we'll talk about internal resistance. See, if you have understood the concept video, these kind of things will be very easy for you. Internal resistance, that is nothing but a resistance offered by the electrolyte. Resistance offered by the electrolyte in the cell or battery. Is called internal resistance. That's it. The resistance offered by the electrolyte in the cell or battery. See, that is nothing but internal resistance is nothing but the resistance of the battery. That's it. Our next question, explain why Potential difference across the terminals of a cell is more in open circuit and reduced in closed circuit. Okay, first we'll talk about open circuit. See, what do you mean by open circuit? When the current is not flowing. When the current is not flowing. See, we know all the cells, okay, all the cells will have EMF. Along with the EMF, it will also have internal resistance. Internal resistance. Okay, when the circuit is open, okay, you have to start like this. When the circuit is open, no current will be flowing. No current will be flowing. So there will be no small v. What is small v? Voltage drop. See, when the circuit is open, no current will be flowing, so there will be no voltage drop because of the internal resistance. Because of the internal resistance. So the same thing, exactly opposite in closed circuit. When the circuit is closed, okay, when the circuit is closed, current will be flowing, and because of the internal resistance, there will be voltage drop. Well, what do you mean by voltage drop? Voltage will be lost. That is why in closed circuit, potential difference across the terminal will be reduced compared to open circuit. That's it. Our next question, how would you connect two resistors in series? Draw the diagram and calculate the total equivalent resistance. Okay, very simple. So how would you connect two resistors in series? And we have to draw the diagram. See, first we need a battery, plus and minus, two resistors. To understand whether they are in series and parallel, you need to learn how to identify the series and parallel connection. That is why I am telling you. So that video is separately available in the description box. Okay, just how to identify it. If you know identification, you can draw it. Assume this is R1 and this is R2. Okay, assume this is 2 ohms and this is 3 ohms. Okay, this is the diagram. Calculate the total equivalent resistance. So REQ, total equivalent resistance, is equal to R1 plus R2. Why? Because they are in series, and that will be 5 ohm. See, this is just an example. You can take any values in the exam to calculate the answer. Our next question, show by a diagram how two resistors R1 and R2 are joined in parallel. Obtain an expression for total resistance of the combination. Listen, obtain an expression is nothing but derive an expression. Derivation based on questions will not be asked in ICSE exam. So here we are going to draw the diagram and we are going to write the final expression. So in any case, they are not going to ask any derivation based problem. Don't worry about it. So here we have given two resistors and we have to connect it in parallel. That's it, R1 and R2. So the final expression will be 1 by Rp is equal to, we have two resistors, right? So R1 plus R2. If you substitute the values, we will get the answer, and finally we have to take the reciprocal. So that you will understand while solving the numericals. That's why I am suggesting it. Now we have solved each and every theory question from the chapter Electricity Part B. The remaining part will be solving numericals. See, numericals from 8B, okay, Electricity B part numericals will be little advanced compared to all the numericals in the physics chapter. So learn it properly, then you will understand. See, there is a reason behind every step. If you understand that reason, the same reason will be for different question also. So understand it properly, solve it, you will get the confidence. Aram se you can score good marks in board exam also. Thank you.